Hello, my IEP2 students. So, in this first video of our online training series, we're going to talk about motors. Yes, using motors. Reference is Sam's Chapter 19. We'll talk about three different things primarily: motors in your microcontroller kit, motors in the Lego kit, which most of you don't have, and that's okay, motors in the Evie Shield, which also you don't have. But I think what we're going to do is use my motors and my Evie Shield and collect some data and have you do a report on that. Not in this lecture today, though. So in your individual kit, you have several different types of motors. You have a DC motor and a power MOSFET, FET, FET for driving it. I would recommend, honestly, not using this motor. It goes very fast. It has some advantages, but there's a disadvantage that's kind of a showstopper for me on the next slide. I'd say if you want to look through the details on this slide in detail, that's fine. This is also in the PDF, so I won't go through every detail here. Second motor type is the stepper motor and driver board. Very nice little motor, pretty slow, good bit of torque. It can be driven very easily by a library that's included in the IDE. You also have in your kits an RC type servo motor that will go 0 to 180 degrees with a significant amount of torque. It will also potentially draw quite a bit of current, and that may drive the need for having an external power supply, that is another battery pack, rather than driving it power-wise directly from the Robo Red board. So something to think about. There's also a library to drive the servo, and that's a good thing. More information on the next slide about the DC motor. Fast, like I said. Smooth shaft, that little smooth shaft, I think it's 2 millimeters. Not so easy to couple to. So that's a little bit of a slowdown for you. Not a showstopper, but consideration. One that I would consider pretty close to a showstopper is that this little motor is pretty electrically noisy. It generates a lot of spikes, and they may cause your microcontroller to freak out, basically. Stepper motor is a nice one. Probably the only disadvantage of the stepper motor is that it's pretty slow, but serves great in a lot of applications, like, hey, maybe a windshield wiper motor. Third motor type that we're going to look at in your MCU kit is the servo motor. We already talked about this a little bit, and I think I won't talk too much more other than to mention that continuous rotation versions do exist. You can purchase those online, or honestly you can make your own if you're good with a soldering iron and an X-Acto knife. Remember, I mentioned that there may not be enough power in the MCU board to drive this servo, so what you might do is instead connect an external battery pack. Just make sure that you're within the allowable voltage range of 4.5 to 6 volts, or you may destroy your servo. So the control signal is coming from the microcontroller, in this example pin 9, in your example or in your application whatever pin you'd like, as long as you support that in the programming. So that's the control pin, and then the power is coming from the battery pack. Notice that the battery pack ground has to be connected to the microcontroller ground. Actually, more precisely, the servo ground and the battery ground have to be connected to the microcontroller ground, or the control pin won't have a reference and it won't work so well. In the Lego kit boxes, which again most of you don't have, you have several different types of motors outlined here. I think we'll skip right past this. Evie Shield, which I have, some of you have. This is what allows the Robo Red to connect to NXT and EV3 sensors and motors, and basically use an Arduino to control EV3 hardware and NXT hardware. And that is the end of our motor slideshow.